Hello friends, welcome again to this channel. Today we are to solve this given problem that there are two equal resistances connected in parallel. It is reflected here that R and R are two resistances in parallel across a 150 volt direct current source. So this is also the direct current voltage source, and you are tasked to get the potential difference exists if you have to consider the midpoint of one of the resistance, for instance this branch. So the midpoint of this R, and the other one is 1/3 from the other resistance, so 1/3 of this R. First, let us know that we can easily get the current in this branch. Since that this is connected in parallel, the voltage in these resistances are the same, and that is 150 volt. So you can right away solve for the current in this branch and also in this branch. That will be I. Okay, so 150 volt divided by R by using Ohm's law. This can be our equation 1. Now let us try to divide the resistances from the other branch. We have the midpoint, consider the midpoint and assign it as A, and the other one is 1/3 and assign this as B. Okay, we place there our voltmeter to get the potential difference. So I'm assuming that A is my positive polarity and B is my negative polarity. You can also have another assumption in which you can make as your A as negative or B as your positive, but for me I place it as this one. So this is positive and that is negative. So again, since we are considering the midpoint of this branch, so we divide R by 2, so the other resistance is R over 2 to make it R, so the other one is R over 2. So R over 2 plus R over 2, that is R, and the other one is 1/3, so we get the R over 3, and to have it equal to R, you just subtract R over 3 from R, so you get 2/3 R. Okay, and then this is our again point AB, and we assign C and D there. Okay, for us to have a clear loop for our Kirchhoff's voltage law, so we are taking the KVL on loop A, B, C, D, A. Now this is my Kirchhoff's voltage law, but first let me just use this notation that my V is equals to the P sub AB. The potential difference at A and B, which I am looking for, is actually equal to V. This is my notation. So my Kirchhoff's voltage law is this one. Since that this is a voltage drop, because this is positive and negative, so I assigned it as negative V on my equation, Kirchhoff's voltage law equation, and this is also here. Okay, since the current is going down here, so this is positive and this one is negative. Okay, so also this one is going down, so this is positive and this is negative. Okay, so if you are to have the path B to C, this will be voltage rise. So I times the resistance, the voltage, so that will be IR over 3, voltage rise, so this is positive. But this one, the A, is voltage drop, so I times R2 is voltage drop, so that is negative, equals to 0. And that can be also rewrite as this one. B, negative B will be positive, this will become negative, this will be positive. Okay, so this is same as this equation. And for further simplification, you just have this equation 2 as b plus 0.167 IR is equals to 0. Now, we substitute equation 1 to equation 2. Our equation 2 is this one, b plus 0.167 IR equals to 0. So instead of using I here, we use 150 over R. So I substitute it here. You will notice that R here is in the denominator and the other one is in the numerator, so that will be cancelled out. So what remains is this one, b is equals 0.167 times 150. And if you are to multiply that, it will give you b plus 25.05 is equals to 0. Now, if you will move this positive value to the right part of the equation, it will become negative. So b here, the value of AB, which is b, is negative 25.05 volts. This is according to my assumption. But since this is negative, if I will make this positive, I will change the polarity of this one. Okay, so this is my answer, and it means that my assumed polarity of AB in the circuit diagram should be reversed to make its value positive. So my voltmeter should be, the A is the negative polarity, and yes, this is negative and this one is the positive. So that's it. Thank you so much for watching this video. I hope that I have shared to you and added information and knowledge to your learning desire. Thank you so much.